Hi students, today we will learn how to graph linear functions by hand. So we have previously learned that the equation of a line can be written in slope-intercept form, which is y equals mx plus b. Remember m, that represents the slope, and remember on a graph the slope, that's the rise or the up and down change over the run, which is the side to side change. So we'll review that. And then the b of our formula of our equation represents the y-intercept. And this is where our graph crosses the y-axis. So we've learned how to pick these two things from a graph and then plug them into here and here to write the equation. But this time we're going to be starting with the equation and pulling those things out of the equation to actually create the graph. So here's what Mrs. D says. When you're doing this, you want to begin with B, the y-intercept, and then you're going to move with M, the slope. So we're going to begin with B and move with M. And if you remember that, that will help you when you're trying to graph these linear functions from the equation in slope-intercept form. So in these examples, we are going to first identify our M and our B. Remember, the form is y equals mx plus b. If you don't know this by heart now, you will. So m is in front of the x. B is the number that's added or subtracted at the end. If it's subtracted, that b would be negative. So pay really close to signs. All right, for this first one, the m, the number in front of x, is 2, but we want to write it as a fraction because we want to be able to physically see the rise and the run. So remember, if you have a whole number or an integer, you can just put that number over 1, and now I've got the rise on the top and the run on the bottom. So we'll use that in just a minute. The b, that's my 4. Okay, so I told you to begin with b and move with m. So we're always going to start with our b. Remember, the y-axis goes up and down, the x-axis goes side to side. That b, that 4, is on the y-axis. So on the y-axis, you're going to go to where positive 4 is. Remember, positive numbers are up at the top, negative numbers are down at the bottom. Zero's right in the middle. So we're going to count up to 4, 1, 2, 3, 4, and we're going to put a dot. That is our y-intercept, our b. Now we're going to move with our m. Our m is 2 over 1. That is positive. So we want our graph to go up from left to right. So just keep that in mind as you're doing this. Now you're actually creating that triangle that we pulled off of those lines. So remember, the top number, that 2, we're going to go up or down. The bottom number, the 1, we're going to go side to side. And we're going to go in the direction that's going to give us that positive looking slope, up from left to right. So I could either count up to 1, 2 from the B, and then count over 1, 1, and then put another dot. I can do that pattern again. Go up to 1, 2, then over 1, then put a dot. Notice when I connect those points, and you want to, you definitely want to use a straight line here. Let me get out my straight line. So you want to use something straight, like something, it doesn't have to be a ruler. It could be the edge of a piece of cardboard or a book or your calculator. As you're doing this, if you're not able to print this off at home, you definitely need some sort of graph paper. If you don't have access to actual graph paper, you can just sketch these grid lines on your notebook paper. You can take the horizontal lines and just use a straight edge to make some vertical lines. It doesn't have to be perfect, but I do want you to practice using that rise and run. So let's take a look at our graph here. We have used that slope from the y-intercept, that 4, and we went up 2, over to the right 1, up 2, over to the right 1, because we wanted to make it go up from left to right, which it does. Now from that 4, I could just as easily have gone down 2, and watch, 1, 2, and then to the left 1, and put a dot there. Oh, Lord, sorry. Go down 2, 1, 2, go to the left 1, put a dot there. But what you want to make sure on these triangles, whether they're above your line or below, that the up and down distance is 2 and the side to side is 1. All right, let's look at number 2. Number 2, your m is in front of the x. That's the negative 3 over 2. And your y-intercept is that minus 3. So your slope is negative 3 over 2. And your y-intercept is negative 3. We're going to begin with that b of negative 3 on that y-axis. So we're going to go down to negative 3, which is below the origin, which is right here at negative 3. Okay. From there, we're going to move with our m. Our m is negative, so we want it to go down from left to right. That means if I was to go up 3, because that's my rise, then I would have to go to the left 2. Or if I was to go down 3, I would have to go to the right 2. So you can do either of those patterns to make that negative slope. I'm going to go up 3 from my y-intercept. 1, 1, 2, 3. And then I'm going to go to the left 2. 1, 2. And I'm going to put a point. Do it again. Don't just do it once. Do it a few times. And then from that point, I'm going to do it again. I'm going to go up 3. 1, 2, 3. To the left 2. 1, 2. Put another dot. If I had chose from that y-intercept of negative 3 to go down instead of starting up, I could go down 3, but then I would go to the right 2. So I'm going to do that. I'm going to go back to my negative 3 y-intercept. I'm going to go down 3, 1, 2, 3, but this time I'm going to go to the right 2, 1, 2, put another dot. So either way you want to do it is fine, and then you want to connect those with a straight edge. And you want to go all the way through your graph. So I kind of should have started up here. Let's see if I can fix this. Up 3 over 2. There we go. That's pretty good. All right, let's try some more. All right, number 3, my m is in front of the x. That's this negative 4. I'm going to put it over 1 so that I not only can see my rise, but I can see my run. All right, my b is what you add or subtract at the end. I don't have anything added or subtracting. That means what was added or subtracted was a 0, which means my y-intercept is 0. So when I begin with b, or I begin with 0, that y-intercept is at the origin on the y-axis. That's where 0 is. From there, I want to make a negative slope of negative 4 over 1. So my rise is 4, my run is 1. So I could either go up 4 to the left 1, or down 4 to the right 1 to keep it negative. I'm going to start by going up 4 to the left 1 from that y-intercept. 1, 2, 3, 4, and then to the left 1, put a dot. I can do it again. Up 1, 2, 3, 4, to the left 1, put a dot. Just the same from the origin, I could have gone down 4 to the right 1. 1, 2, 3, 4, to the right 1, put a dot. Once you get a few points, now you're going to line those up with your straight edge. And you are going to connect those points with a straight line. There you go. Number 4, the m is in front of my x. That's positive 5 over 3. The b, the y-intercept, is negative 4. So positive 5 over 3, negative 4. You can get in the habit of circling those, highlighting those, however you want to do it. And we're going to begin with b. Begin with that negative 4. That's below the origin on the y-axis. That's right here. Oops. It's hard for me to put points when I'm doing this. All right, now we're going to move with m. That's a positive slope. So we want it up from left to right. That means if I went up 5, I would go to the right 3. Or if I went down 5, I would go to the left 3. Either one will work. I'm going to start by going up 5 and then to the right 3. 1, hold on, 1, 2, 3, 4, 5, to the right, 1, 2, 3, put a dot. Do it again. 1, 2, 3, 4, 5, to the right, 1, 2, 3. So when you're doing this, make sure that you're counting spaces and not lines. And then you can go ahead and connect those little guys with a straight edge. All right. Now there is another form of the equation of a linear function that's called standard form. And it looks like this. AX plus BY equals C. Okay, so let's explain this. So this looks a little bit different than y equals mx plus b slope-intercept form. That form was really great because I could see that y-intercept and I could see my m, my slope. However, in standard form, I can't see either of those because m and b are not visible. They're there, but they're not visible. The capital A, capital B, and capital C, those are just constants or coefficients, but they aren't necessarily the slope or y-intercept. They're kind of hidden. So what we need to do is, if we want to graph from this form, we have to solve for y. Now we did this at the very beginning of the year, and when we do that, we will get it in slope-intercept form. So there are basically 2 steps to solve for y, and we'll practice this on these examples. And you did this at the beginning of the year, but you may not remember. Step 1, you're going to add or subtract, whatever's the opposite. We're just kind of moving some things around, trying to get y by itself. We're going to add or subtract our x term to both sides. And that will move that x term to the right side so that it starts to look like this right here. The next thing you're going to do, you'll have just by on the left, but you've got to get rid of that b, that coefficient of y. So the second step you'll do is you will divide every term by the coefficient of y. Oh, sorry, this handwriting is so ugly. I'm trying to make it look pretty. So that number in front of y, the coefficient of y, you're going to divide every term by that, simplify, and then you will be able to see your m and your b because then it'll be in slope-intercept form. So we're just adding 1 extra step before we graph, actually 2 extra steps. So let's see what this looks like. All right, so remember, we want it to look like y equals mx plus b. With this example, we're almost there. The only thing we really need to do is get that x over, and then we're done. Our coefficient in front of y is a 1, so we're not going to have to divide everything by that. So this one, we only need to do that first of the 2 steps. All right, so remember, we're trying to get y by itself. So the first thing we're going to do is add or subtract that x term to both sides. Our x term is positive, so we're going to subtract it from both sides. This goes away. We've got y on the left equals, on the right, we've got these 2 terms, but they cannot combine because they're not like. To make it look like slope-intercept form, we're going to put the x term first, followed by the constant. Now it is in slope-intercept form. So now we're ready to pull out our m and to pull out our b so that we can graph. Remember that m is the number in front of your x. In this case, it looks just like a negative. Well, we can think of that as a -1. And if I want to make it as a fraction or rise over 1, we can think of it as -1/1. So whenever we're graphing, it's helpful to have both the numerator and denominator of our slope. The b is the number added or subtracted at the end. In this case, it's the 3. All right, so now we're going to practice graphing again. This is what we've just been doing. On the y-axis, we're going to begin with our b. Our b is 3, so we're going to put a dot at 3. If I can do my dots. There we go. From there, we have a negative slope, so we want our graph to go down from left to right. So if I went up one, I would go to the left one. Or if I went down one, I would go to the right one. Let's do that. I'm going to go up one, whoops, and then go to the left one, put a dot. Or I could go down one and to the right one, put a dot. All right, then we're going to connect those after you get a few good dots. Let's see if I can do this right. Trying to make sure my slope looks pretty good. So there is our graph. All right, here's another one that's in standard form. Remember, we need to make it look like y equals mx plus b first so we can see that slope and that y-intercept so it's easier to graph. So step one, we're going to move our x term to the right by adding or subtracting it from both sides. The 3x is positive, so we're going to subtract it from both sides, minus 3x. So we've got negative y equals, remember these two terms, the negative 6 and the negative 3x are not like. We're going to put the x term first and then followed by the constant. So negative 3x, then follow with that minus 6. Step 2 is to get rid of the coefficient in front of your y. In this case, it's a negative 1. Remember, there's always a 1 there if you don't see a number. So we're going to divide every single term by a negative 1. And anytime you multiply or divide by a negative 1, you're really just changing the sign of that term. So negative 1 divided by negative 1 is 1, so we've got 1y, or y, which is what we want. On the right, we're basically going to simplify these fractions. So negative 3 over 1 simplifies to positive 3. I might want to keep it as a fraction, though, because it's going to be more useful when I'm graphing. And then the negative 6 divided by negative 1 is going to be a positive 6. But I'll keep that as a whole number because my y-intercept is more helpful as a whole number or integer. Now we're going to identify our m and our b. So our m is the number in front of our x, which in this case is 3 over 1. There's our rise and run. The b is the number at the end, which in this case is 6. We're going to begin with b. So on our y-axis, we're going to go up to 6. 1, 2, 3, 4, 5, 6. Put a dot. Our slope is positive, so we want it to go up from left to right. So if I went up from 6, 3, I would go to the right one to get to my line. Or if I chose to go down 3 from my 6, I would go to the left one to get back to my line. So I'm going to go up 3, 1, 2, 3, into the right one, put a dot. Or I could have chosen to go down 3, 1, 2, 3, into the left one, put a dot. If I can do my dots. All right, then you're going to take a straight edge, line those dots right up. And you can do that slope as many times as you want until you can get that straight line. Remember what these lines represent. It's not just those 3 points that I drew that are on the line. Every point, the line is made up of millions and millions of points that are strung together. So all of these points are now on this line. All right, if you feel like you're starting to get good at this and you want to pause at some point and try some of these examples on your own and then unpause and see how you've done, you are welcome to. All right, here's another one in standard form. We got to get it into slope-intercept form, y equals mx plus b. So the first thing we're going to do, we're going to move our x term to the right side by adding or subtracting it. Our 2x is positive, so we're going to subtract 2x from both sides, because that's the opposite. We get negative 3y on the left equals negative 9 and negative 2x are not like terms, but I do want to list the x term first, that negative 2x, and then follow it with my constant, that minus 9. Step 2 is divide every single term by the coefficient of y, which is negative 3. And then we're going to simplify. Negative 3 divided by negative 3 is 1y, so just y. We're going to simplify both of these fractions. Remember, keep the slope as a fraction. Negative 2 over negative 3, I've told you if you have a negative in the top and in the bottom, negative divided by negative is a positive. So that's the same as positive 2/3 x. Don't forget your x. And then negative 9 divided by negative 3 is positive 3. So my m is positive 2/3. My b is 3. Positive 2/3 and 3. M and b. All right, so here we go. We're going to begin with b. On our y-axis, we're going to go up to where positive 3 is and put a dot. Our slope is positive 2/3, so I can either go up 2 to the right 3, or I can go down 2 to the left 3. If I go up 2, 1, 1, 2, I'm going to go to the right, 1, 2, 3, put a dot. Or you could go down 2, 1, 2, and to the left 3, and put a dot. Then you take your straight edge, you line everything up real nice like. And let's see, boom. There's your line. All right, here's the last one we're going to graph. Again, we want to make it look like y equals mx plus b first. The only thing I have on that left side besides my y is just my 3, so my x term is on the right already. That's good. I don't have to do that step 1. So step 2 is to divide every term by the coefficient of y, which is 3. 3 divided by 3 is 1. 1 times y is y, equals 6 over 3, simplified, because that's going to be my slope, is 2 over 1, and then x. And then I don't have anything added after it, so it's kind of like there's a plus 0. If you don't see anything and you want to put that plus 0 there to make you feel good, you can. Let's identify our m and our b. Our m is in front of x, that's the 2 over 1. Our b is what's added or subtracted at the end, which is nothing, so our b is 0. We're going to begin with b. On the y-axis, your y-intercept is 0. That's right at the origin. Because I have a positive slope from there, if I go up 2, I'm going to go to the right one. If I go down 2, I'm going to go to the left one. So I'm going to go up 2, 1, 2, to the right 1. And remember, I can do this as many times as I want. Up 2, to the right 1. I could do it the whole length of the graph if I wanted to. However, I just need 2 or 3 points to make a good line. So once you find those points, line them up nice and neat. And connect them with the straight line. All right, so that's the graphing. Now, with any of these, after you graph, if you want to double check with your calculator, you can go to the graphing part of your calculator, and you wouldn't want to type in this equation, okay? When you're in your graph, it's defaulted to y equals, or it might say f of x equals. So what you're going to put after the equal sign is this part, after you've put it in slope-intercept form. So you still need to have that skill. So you would type in, like for this one, you would just type in this part right here into your graph, enter, and it will graph and make it look like this. So if you do that and you get something totally different, you might have gone from here to here incorrectly, or maybe you just used your m and your b wrong on your paper. So do these by hand, but then also double check on your calculator. All right, we got one more example that's not graphing. Oops, I lied. We actually have 2 more graphing examples, but these 2 are special cases, okay? So let's talk about these 2. Remember, you always want your equation to look like y equals mx plus b before you start graphing. So in this first equation, I don't have an x term at all. So what's going to happen is I'm going to have a special case. If you guys remember, there were 2 kinds of slopes that we talked about. If you had a slope that was horizontal, then its equation is always going to be y equals, and because I have a 0 slope, 0 times x goes away, so it'll be y equals whatever number is right here on your y-axis, okay? The other special case is if you had a vertical line. A vertical line's equation is always x equals, there's no y involved at all, and it's always x equals whatever number it crosses here on the x-axis. So if you notice in both of these equations, I only have one type of variable. So the first thing we're going to do is just solve for that variable. So this form of a line isn't going to be very helpful to us. If you have just one variable, remember it's either going to look like y equals and be a horizontal line or x equals and be a vertical line. So on number 9, if I was to get y by itself, I would subtract 7 from both sides. So I'm going to end up with y equals 0 minus 7 is negative 7. Oh, good Lord. Sorry, my handwriting is so bad. Okay. So remember, if it's y equals a number, it's a horizontal line through that number on the y-axis. So negative 7 on the y-axis is 1, 2, 3, 4, 5, 6, 7. It's right here. So I'm going to put a horizontal line right through there. There is my graph. Let's look at the other one, also with just one variable. So I'm going to solve for that variable by adding 2 to both sides. I want to get that x by itself. So x equals 0 plus 2 is 2. So remember, if it's just x equals a number, it's going to be a vertical line through the x-axis at that number. 2 on the x-axis is right here. So I'm going to put a vertical line through all of the points that have an x value of 2. So that's what those equations look like. Remember these special forms of the equation. All right, now this is the last example. All right, which ordered pairs are solutions of the equation? Basically, remember what solutions are. They make the equation true. You can also think of this as if I was to put this in slope-intercept form and graph it, which of these points would be on that line? So that's what we're going to figure out here. And the way to do that this way is the easiest way is to just plug it in. So you've got an x and a y for each point. You're going to put the x value here and the y value here. If you then just type that into your calculator under the calculate part and press enter, it'll tell you whether it's a solution of the equation or not. Now remember, when you have two variables in an equation, there are an infinite number of solutions. Every xy pair is not a solution, but there are an infinite number that are. You just have to pick the right ones. So we're going to evaluate each of these. So for the first one, it would be 2 times negative 7 minus 5 times negative 3 equals 1. You would type that into your calculator. For B, it would be 2 times positive 7 minus 5 times positive 3 equals 1. For C, it would be 2 times 2 minus 5 times 1 equals 1. And for D, it would be 2 times negative 2 minus 5 times negative 1 equals 1. So what we did is we're just replacing x and y. So x and y, x and y, x and y, x and y. And then you'll just type all these in and see which ones are true or not. So let's try that. So take a sec and try it. Okay, so the ones that worked were A and D. B and C were false or untrue. They did not make the left and right sides equal. All right, let me know what questions you have. See you soon. Or actually, I'll see you next class. I am giving you a little bit longer to do the assignment in case you do have some questions, but please reach out to me if you do. See ya.